All right, you guys, welcome to 3B. I know we kind of sort of did this backwards, but we are in section 3.1. We're going to talk about parallel lines. We're going to talk about transversals. We got a whole bunch of angles coming up. It's going to be all good. So the first thing I want to talk about is just a little bit of a review of what parallel lines really are. We just talked about this last chapter. Remember, parallel lines are lines that are coplanar, and they do not intersect each other. And remember, parallel lines also have the same slope. This new thing here is skew lines, kind of a funny little word. Skew lines are non-coplanar, meaning they do not have to be in the same plane. But these also do not intersect. So this is a double knot. Okay, non-coplanar, do not intersect. Skew lines are a double knot. Parallel planes, you guys. Parallel planes are just simply planes that do not intersect each other. So in the example below, and we're going to see it on the next page here, plane ABC is going to be parallel to plane EFG. So what happens is on this next page we have this wonderful looking cube, and I'm going to try to draw this for you guys as best as I can. Oh boy, that was awful. Let's redo that. I apologize. Let's take a look. I'm going to draw this, and I'll draw this one, and then we'll connect the dots. It should be a little bit better. There we go. So what happens is, in this next drawing here, plane ABC is actually this top part, and EFG is actually the bottom part. And these are going to be parallel planes. They're like the bread of the sandwich, the top and the bottom, but they do not intersect each other. Okay, so as you can see from this picture that's drawn a little bit nicer, plane ABC, which is on the top, ABC up here, and EFG down here are our parallel planes. Okay, so let's take a look at this first example. It says I want you to name all of the segments. So name all of the segments that are parallel to EH. So let's take a look. Where's EH? Well, EH is right here. The definition of parallel, so parallel has to be lines that are in the same plane but do not intersect. Well, lines that would be in the same plane that don't intersect, one of them would be AD. They're that left plane there, so we have AD. And another one that's in the same plane that does not intersect would be GF, or if you want to say FG. And if you notice, that's pretty much about it. Okay? So in order for them to be parallel, they have to be in the same plane and not intersect. The next one asks you to name all the segments that are skewed to EH. So again, we're looking at EH. Let me do some erasing here. We'll use some different colors. So again, we're looking at EH, and I want ones that are skewed. So what I want you to do is go ahead and try to find the skew ones. Remember, these are non-coplanar, so they're not in the same plane and do not intersect. Let's see if you can get them all, and then we'll come back together. All right, so what you should have had is we've got BC up here. BC, not in the same plane. However, these do not intersect. We've got CG, CG here, clearly not in the same plane, but these lines don't intersect either. We've got BF, we've got DC, and we've got AB. Okay? Anything that's left over either intersects with it or is in the same plane. All right, you guys, we're going to talk about what a transversal is. A transversal is simply a line that intersects two or more lines in a plane at two different points. So I've got two different examples here. Here's two lines, and here is this line right here that cuts through both of them at two different points. Okay, so because this line cuts through at different points, that makes this line, the blue one, the transversal. It cut through two or more lines at different points. A classic example, and one that you're probably going to see more often, is one that looks like this. I'm going to give you two parallel lines, and I'm going to give you a line that cuts through it. This line is cutting through at 2 different points. That makes it the transversal. But what's going to be special about this are the angles that are going to be formed. So your angles that are going to be formed at these crossing points are actually going to have some relation to each other when you make them parallel. So a transversal is a line that cuts through 2 or more lines at different points. Alright, so here's this classic picture that I told you about. You've got line A and B, and I'm telling you that line A and B are actually going to be parallel to each other. Line C, hopefully you've noticed, C is this line that cuts through A and B at 2 different points, so C is actually our transversal in this case. And what happens is, because the transversal runs into these parallel lines, we end up with these angles here. These angles have special qualities to them. The first of which is actually what we're going to call alternate interior angles. Alternate meaning opposite sides, so going back and forth between the 2 sides. Interior meaning in the inside. So if you take a look at just this picture in general, the interior angles, or the angles in the inside, are 3, 4, 5, and 6. These are in the inside of what my figure is, or what this creates, these lines in the transversal. So if I want alternate ones, that one means one on one side, one on the other side, our first set that you should see are 3 and 6. 3 and 6 are in the inside, but they're on alternate sides of my transversal. So 3 and 6 are going to be alternate interior angles. Now another set of alternate interior angles, hopefully that you saw, were 4 and 5. These are on opposite sides of the transversal, but they're also in the inside. So 4 and 5 are here. Now, to help us remember this, the alternate interior angles actually make these letters Z's. Alternate interior make these letters Z's. Okay? So alternate interior angles make the letter Z. Alternate exterior. Again, there's that word alternate, meaning on either side of this transversal. However, now we're talking about exterior angles. Exterior angles are the angles on the outside. So we're talking about the angles 1, 2, 7, and 8. So if I'm looking for alternate exterior angles, one of those would be 1 and 8. Both of these are exterior angles. One's on one side of the transversal, one's on the other. So I've got angle 1 and angle 8. Now, if you take a look, there's another pair. They're actually here, 2 and 7. So if I've got 2 and I've got 7 here, these are also my alternate exterior angles. Now, the alternate interior angles made the letter Z. These ones actually go through and make the letter V. They're V's at the corners. So alternate interior angles make the letter Z. Alternate exterior angles make the letter V. And if you have me, this is Feliniac here, we're actually going to be learning a cool little song to help us figure out and remember what these angles are. Alright, the next set of angles that this makes are same side C, which are the interior angles. Same side C, interior angles. Now, same side meaning that we're working on one side of our transversal, and then interior angles meaning that they're the ones in the inside. So if you take a look, 4 and 6 are my interior angles that are on the same side here. So I've got 4 and 6 on one side, and on the other side I have 3 and 5. Now there's a little key here, same side C interior. Well, these same side C interiors make the letter C. Same side C interiors. Okay? The very last ones are corresponding angles. Corresponding, there's no hint in the word corresponding, like there is for alternate interior, alternate exterior, and same side C. However, the corresponding angles are going to make the letters F. Okay, so if you take a look at your picture here, one of them will be interior, one of them will be exterior, and in this case, one of the F's that I make right here, if I were to make an F right here, it would be angle 4 and angle 8. So I get angle 4 and angle 8 This makes an F. Okay, now you could have also looked the other way and said 3 and 7. Now, even though this is a backwards F, 3 and 7 are considered corresponding angles. They do make the F. Now, you can go upside down as well. Okay, if you go upside down, you'll see that 6 and 2 also make an F here. And if you go the opposite way, if you flip it like we did before, we've got 5 and 1. Okay, so a review. Alternate interior, make Z's. Alternate exterior, make V's. Same side C, make C's. And corresponding angles, make the F. All right, make sure that you come with your questions tomorrow, and we'll see you.